says in the reaction box, place the best reagent and conditions from the list below. So I'm going to redraw this, and basically it says here I have a dibrom. I have a kind of but this IUPAC name would be what 2,2,3-dibromobutane. So that's what I would have here. I would have Br and Br. And what I need is I want to react it to form kind of this alkene with bromines on each side here. So I have alkene, and this is in a trans type of configuration, right? Again, oh sorry, oh no, I didn't want to clear everything. My bromines are on the opposite side of the double bond, so this is a trans configuration. So it's something that we're kind of familiar with here. So what reagents would get us there? And there's actually a box here, which is nice, to provide us with the best possible solution. So again, what we have here is alkyl halide. Do some blue. We have an alkyl halide. And I want this would be this is something in terms of this would be a alkene with a bromide. So it's also alkyl halide, but you can say it's there's an alkene with two BRs like trans to it, right? Again, there's just a trans alkene with two BRs or two bromines. You say trans alkene with two BRs. So which reagents would get us there? So let's look at the box here. So let's look at, oh, I zoomed in. That's awesome. So what I have here is, again, I have excess NaNH2, which is sodium amide. That's a base. So we can use that, actually. That's a great way for us to deprotonate and eliminate our bromines. So it creates a double bond. That's good. BH3THF wouldn't give us with water, it would give us a alcohol instead, so that's not it. NaOH is simply a base, so I would get a hydroxyl group. HBr would just wouldn't do much here. Maybe in the second step it might do something. PBr3, again, you just get selectivity of bromination. It's just a bromination. Lindlar's catalyst doesn't do anything with my alkyl halide with the alkene double bond, because again that just reduces alkynes to alkenes. Bromine 1 equivalent doesn't really do much here. The acid here wouldn't reduce my base here. It would actually just make an OH group, so another hydroxyl. CH3Br does not react with another. Alkenes don't react with each other. NHBH4 would be simply just a reducing agent. So again, I don't have a carbonyl group here. So the only option here is actually NaNH2. So this is sodium amide. And what does sodium amide do? It's going to eliminate. It's going to eliminate my bromines here. So if I look at, I can add here this NaNH2. NaNH2. What it's going to do, this is sodium amide. What this does is it deprotonates, or what it's going to do is going to react with my hydrogen. It's going to react with my hydrogen here, right? So I have two hydrogens here, and what it's going to do is I'm going to draw out the mechanism for you. This is a E2 elimination. So it's a E2, which means it's a bimolecular elimination, and this happens all in one step. So basically what this does is the negative anion from NH2 is going to go and attack this hydrogen here. So this hydrogen is going to go this way, and then it's going to kick bromine out, because bromine is going to leave and it's going to get kicked out. And then I am going to form a double bond here. I'm going to form something like this. I'm going to get something like this. And it's going to eliminate one of those bromines, right? So I'm going to get something like, so I would have I would have a double bond here. I would get one here, and this would be a Br here, right? So I would get this as kind of my secondary here. And what I could do is this, again, this is an E2 reaction, right? So I'm eliminating the hydrogen here, the bromine gets kicked out, it's a good leaving group, it's gonna get kicked out, and then it's going to eliminate across this double bond here. So it kind of looks something like this, but I need another Br in this position here, right? So what I can do is, again, I can eliminate again. I can do another equivalent of NaNH2. So I'm using the exact same equivalent. So that's why this is the hint. It says excess NaNH2, right? So in reality, you actually need two equivalents here. So this is NaNH2. And what it's going to do is going to, again, do an E2, right? This minus here is going to attack, it's going to eliminate this bond here on H, right? This H here. and then it's going to, again, what it's going to do is going to go, this minus is going to attack this hydrogen here. It's going to, which then eliminates the bond and kicks out this bromine, right? So I'm going to get now an even different molecule. I get a triple bond, right? I get a triple bond here, and then just basically a triple bond here. So I get it's 1, 2, 3, 4. I get it's still a 4-carbon molecule, but this second bromine got kicked out, and I'm getting a triple bond here. So I have an alkyne now here. This is an alkyne. So that's what sodium amide does in this particular case. Alkyne, and then all I'm gonna have to do is the second step, because this is the first step, right? I add NH2, it's going to do an E2 twice, so it eliminates twice. I get an alkyne, so from an alkene to an alkyne, and then what I'm gonna do with this one is how do I get from here to this alkyne to my alkene with two more groups trans to it, right? I'm simply just going to have to add Br2, right? Br2 with one equivalent is going to give us, it's going to add across this double bond, and it can add trans to it, right? So again, Br2 with one equivalent of Br2, not two equivalents, because Br2 would add, there's 2 bromines, which means it will add across the triple bond here. So one equivalent. So what it's going to do, again, it's going to, this minus bromine has a negative charge here. This bromine is going to attract very much. This bromine is going to basically add across this double bond here, and then I'm going to get a get this product here, because it's one bromine is going to add across this here, one Br here and one Br here, right? So it's going to get this formation here. So that's what the bromine does here. So again, the answer here is NaNH2 and Br2 here. So let's see, and which is correct, right? So again, they didn't really show their work here. I showed the kind of elimination 2 mechanism here, and then Br2 it simply just adds to the triple bond, right? And adds trans to the triple bond here. In this case, so that's what we're doing, and that's our question 1. So this is pretty good. This is question 1 for our organic chemistry unit. Simple double elimination. So E2, so this here is a, maybe I'll highlight this in blue. E2 elimination, this here is another E2 elimination, and this is simply just addition reaction, right? Br2 just adds to, it's adding to this triple bond, right? So simply just addition here. So very, very easy in terms of what we're doing here. So that's number 1, so that's good. Yeah, that's number 1 here. So let's look at number 2. So the solution again is correct, right? So I can say here that this solution, great solution, but I wish there was more. I wish you showed the mechanism of action, the mechanism behind NaNH2, the E2 elimination, behind the E2 elimination using sodium amide, and the addition reaction with Br2 across the triple bond. But either way, the solution is correct, right? So I'm going to say the solution is correct, and that's our number 1.